In the vast tapestry of nature, some creatures stand as living paradoxes, challenging everything we think we know. And for humans, observing them is like peering back into the dawn of time. What if I told you there's a creature on Earth that combines the features of a porcupine, a kangaroo, a bird, and a reptile? A creature that defies the very definition of mammal as we commonly know it. Echidnas, Earth's ancient enigma, a unique mammals that defy all rules. For centuries, scientists puzzled over its true nature. Is it a bird, a reptile, something entirely new? Today, we unlock the secrets of one of Earth's most ancient and mind-bending animals. Prepare to have your understanding of life on this planet completely reshaped. Welcome, fellow curious minds, to the astonishing, the perplexing, the truly spectacular world of the echidna. To truly appreciate the echidna, we first need to understand its lineage. It's not just an animal, it's a living, breathing paradox, a direct link to a time before mammals dominated the Earth as we know them. Our planet is teeming with life, and we broadly categorize mammals into two major groups: placental mammals, dogs, cats, whales, where babies develop fully inside the mother's uterus, nourished by a placenta. And then there are marsupials, like kangaroos and koalas, whose young are born underdeveloped and complete their growth in an external pouch. But then there's the third group, the monotremes, and this is where the echidna shines. Monotremes are the only mammals on Earth that lay eggs. Let that sink in. Egg-laying mammals. It sounds like something out of a mythological beast collection, not a real scientific classification. Monotremes are unique among mammals because they lay eggs, setting them apart from all other living mammals that give birth to live young. The only living monotreme species are the platypus and 4 species of echidnas, all found in Australia and New Guinea. Despite laying eggs, they are still classified as mammals because they have hair and produce milk to feed their young, though they lack nipples and secrete milk through pores on their skin. The discovery of monotremes, particularly the platypus and then the echidna, baffled early European naturalists. They sent specimens back to Europe, and scientists simply didn't believe they were real, or thought they were elaborate hoaxes stitched together from different animals. It challenged every preconceived notion of how mammals evolved and functioned. Our story is ancient. Genetic evidence suggests that the monotreme lineage diverged from other mammals during the Jurassic period. Think about that. They were around when dinosaurs roamed the Earth. They represent a highly successful, yet independent branch of mammalian history, proving there's more than one way to be a mammal. They didn't just survive, they thrived, perfectly adapted to their unique niches. Let's get up close and personal with the echidna's extraordinary design. Every part of its anatomy is a testament to many years of specialized evolution. First, the most obvious feature, those formidable spines. These aren't like porcupine quills, which are designed to detach. Echidna spines are actually highly modified hairs made of keratin, the same material as our fingernails and hair. They are firmly rooted in their skin and don't detach easily. Each spine is incredibly sharp and rigid, providing an almost impenetrable defense. When threatened, an echidna's first instinct is often to dig straight down into the earth with astonishing speed, using its powerful limbs and claws. Within seconds, it can partially bury itself, leaving only a bristling spiny dome exposed. If it can't dig, it curls into a tight spiny ball, protecting its vulnerable belly. It's a living, breathing pincushion. Now, let's talk about the star of the show, the snout. This isn't just a nose, it's a natural marvel, a highly sensitive sensory organ and a precision tool. It's elongated, cylindrical, and slightly upturned in some species, like a blunt probe. What makes it truly unique is its ability to detect prey using electroreception. Yes, like a platypus. The echidna's snout is covered in thousands of tiny receptors that can detect the minute electrical impulses generated by muscle contractions of insects, even when they're hidden underground or beneath bark. It's like having a built-in metal detector for ants and termites. This allows them to precisely pinpoint their prey, even when vision and smell aren't enough. And once prey is detected, out comes the tongue. This is not your average mammalian tongue. It can extend up to 18 centimeters, that's nearly 7 inches, well beyond the length of its snout. It's covered in sticky mucus, acting like a super-fast adhesive conveyor belt. With incredible speed, the echidna can flick its tongue in and out, slurping up thousands of ants and termites in a single feeding frenzy. The tongue is incredibly muscular, anchored deep within its body, allowing for rapid protraction and retraction. It's a specialized feeding apparatus perfectly designed for its insectivorous diet. And surprisingly, echidnas don't have teeth. Instead, they crush their prey between horny pads at the back of their mouth and on the roof of their palate. So, where do these incredible creatures call home? Echidnas are truly unique to the Southern Hemisphere, found exclusively in Australia, Tasmania, and New Guinea. Their adaptability is astonishing, spanning a vast range of environments. We primarily recognize 4 species of echidna, each with its own specific niche. The most common and widespread is the short-beaked echidna, Tachyglossus aculeatus. This is the one you're most likely to encounter across almost all of Australia, from the scorching arid interior to the chilly snowy mountains, dense forests, and even surprisingly, the suburban edges of cities. Their adaptability to diverse climates and food sources is a key reason for their success. Then, we have the 3 species of long-beaked echidnas, all native to the island of New Guinea and some islands in its vicinity. These are the western long-beaked echidna, Zyglossous brownii, Sir David's long-beaked echidna, Zyglossous attenboroughi, and the eastern long-beaked echidna, Zyglossous bartani. The long-beaked echidnas are generally larger than their short-beaked cousins, with significantly longer, down-curved snouts, which they use to probe for earthworms and insect larvae in the rich forest floor. Sadly, these species are far more elusive, and all 3 are classified as either critically endangered or vulnerable due to habitat loss, hunting pressures, and climate change impacts. The rediscovery of Sir David's long-beaked echidna in 2023, after decades of no confirmed sightings, was a monumental moment in conservation. Each species has evolved its own unique adaptations, but they all share that fundamental monotreme heritage and the incredible ability to survive in environments that would challenge most other mammals. Now, let's talk about what truly sets the echidna apart in the mammalian world: their incredible reproductive strategy. This is where it gets truly wild. After breeding, which by the way involves a fascinating echidna train where multiple males follow a single female for weeks, the female lays a single, soft-shelled, leathery egg. This isn't just any egg. It's relatively small for the size of the animal, about the size of a grape or a small jelly bean. And where does this egg go? Not in a nest, not buried in the ground, but into a temporary muscular pouch that forms on the female's abdomen. Yes, a mammalian pouch for an egg. It's a marvel of evolutionary convenience. The egg is incubated there for about 10 days. Then, a tiny, blind, hairless, jelly bean-sized baby emerges. This is perhaps the most endearing stage, the puggle. The puggle, though newly hatched, has enough strength to wriggle around in the pouch until it finds the specialized milk patches. And this is another incredible difference. Female echidnas don't have nipples. Instead, they secrete milk directly from pores on specialized milk patches within the pouch. The puggle simply laps up the milk from these patches, growing rapidly. The puggle remains in the safety and warmth of the pouch for approximately 45 to 55 days, or until its spines begin to develop and become too prickly for the mother's comfort. Once the spines become too sharp, the mother carefully deposits the puggle into a nursery burrow. She doesn't abandon it. She continues to return every few days to nurse the puggle until it's about 7 months old and strong enough to venture out on its own. This extended maternal care, combined with the unique egg-laying and milk-feeding mechanism, is a testament to the remarkable development of monotremes. It's a complex, energy-intensive process, but one that has allowed them to persist for millennia. This unique combination of egg-laying with milk production highlights their distinct and highly successful adaptation. Despite its energy demands, this method of reproduction has proven incredibly effective, contributing to their long-term survival in challenging environments and underscoring their resilience and ability to thrive in their specific niches, even alongside other mammals that give birth to live young. Echidnas are, for the most part, solitary creatures. They live quiet lives, often unseen, diligently going about their business of finding food and avoiding predators. Their daily routine largely revolves around foraging. They spend a significant portion of their time methodically searching for ants, termites, and other invertebrates using their keen sense of smell and, of course, their unique electroreception. They're often seen tearing open rotten logs or digging into ant mounds, their powerful claws making short work of even hardened earth. While they have tiny eyes, their eyesight isn't their strongest sense. They rely heavily on their sense of smell and hearing. They have an incredible ability to regulate their body temperature. Unlike most mammals, their body temperature can fluctuate more widely. When temperatures drop, they can enter a state of torpor, a kind of mini hibernation, to conserve energy. In extreme cold, they can even truly hibernate for extended periods. This flexibility is crucial for surviving in Australia's often harsh and unpredictable climates. Despite their spiny defense, echidnas do face predators like dingoes, foxes, feral cats, and even large birds of prey. Their primary defenses are their spines and their ability to dig themselves into the ground with incredible speed or curl into a tight, spiny ball. Sometimes, they'll wedge themselves into crevices, bracing their spines against the rock. And don't let their appearance fool you. When they want to move, they can scuttle along at a surprising pace. They might look clumsy, but they are incredibly agile for their body type, especially when navigating dense undergrowth. For Indigenous Australians, echidnas have always been an important part of the landscape, featuring in Dreamtime stories and traditions. For many non-Indigenous people, their first encounter with an echidna is often a moment of surprise and awe. However, human activity also poses significant threats to these ancient mammals. One of the leading causes of echidna mortality is road accidents. They are slow-moving and often cross roads, especially after rain when their insect prey is more active. Drivers often don't see them until it's too late. Habitat loss and fragmentation due to urbanization, agriculture, and land clearing are also major concerns. As their natural homes shrink, their food sources diminish, and they become more vulnerable to predators and human interaction. Climate change, leading to more frequent and intense bushfires, is another devastating threat. While echidnas can often dig deep to escape fire fronts, the loss of vast tracts of habitat and food sources post-fire can be catastrophic for their populations. Feral animals like foxes and cats also prey on adult echidnas, and especially vulnerable puggles. The good news is that conservation efforts are underway. Organizations are working to protect their habitats, rehabilitate injured echidnas, and educate the public about their importance. Every effort helps ensure these unique creatures continue to thrive. So, beyond their sheer biological uniqueness, why do echidnas matter? They are far more than just oddities of the animal kingdom. They are ecological powerhouses, performing vital roles in their environments. As they dig and forage for insects, echidnas constantly turn over and aerate the soil. This process is incredibly beneficial. It improves soil structure, allows water and nutrients to penetrate deeper, and helps decompose organic matter. Essentially, they are natural gardeners of the Australian and New Guinean bush, fostering healthier plant growth and supporting entire ecosystems. Furthermore, their insectivorous diet helps control populations of ants and termites. While these insects are vital components of the ecosystem, unchecked populations can cause problems for plants and even human infrastructure. They are also a critical part of the food chain, supporting larger predators in their native environments. Their very existence is a testament to the incredible diversity and resilience of life on Earth. Each unique creature holds invaluable lessons about adaptation, survival, and the intricate balance of nature. They stand as a living example of how distinct strategies can lead to lasting success, demonstrating the vast and sometimes unexpected ways life can thrive. The echidna is more than just a spiny egg-laying mammal. It's a living bridge to an ancient past, a master of adaptation, and a vital thread in the tapestry of our planet's biodiversity. Their continued existence is a triumph of evolution. I hope this deep dive into the world of the echidna has inspired you as much as it has me. These are truly spectacular creatures, and their future depends on our awareness and action. If you learned something new or were simply amazed by the echidna, please hit that like button right now. It helps us reach more people and share these incredible stories. Share this video. Spread the word about the echidna. The more people who know about them, the better. Thank you for joining me on this incredible journey. Let's continue to be curious, to learn, and to protect the wonders of our natural world. Until next time, stay wild and stay curious.